Hey folks, happy Saturday. Hope everyone is doing well. I'm just double checking. Had to rearrange my setup a little bit, so just double checking that the audio and video is coming through okay. It looks like it is. I'm going to unmute this here in my headphones for just a second. Yep, sounds good on my end. As always, if there's any audio or video troubles, feel free to just jump in chat and let me know, and we'll get those sorted out. But the past couple streams, it seems like we've been pretty set in terms of things not going off the rails. So hopefully that will continue today. Let's go ahead and kind of jump into some of our show planning. So I'm going to switch over to sharing my screen. And I've kind of been thinking about, we use Excalidraw obviously a lot in here, and a lot of times after a show I'll try to synthesize something we talked about, and post that on social media or something like that. But I thought it would be pretty cool to take this infinite canvas idea and kind of just have like ongoing show notes. I've also thought about using Figma, which is a little more exact perhaps. Actually, well, one of the things I like about Excalidraw is I don't have to be logged in and I can just export it. So maybe we'll go with that for now, or maybe something like Figma. Yeah, actually, I'm going to switch over to Figma here and see if I can get logged in. So we'll switch over to just my face for a moment here. And I am going to get signed in to Figma, and then we'll use that going forward here. So let me jump over there. Obviously, I know y'all can't see what I'm doing, but I'm just going to get signed in, and then we should be good to go. All right, let's see. Yeah, it's all just connected to my Google accounts. So we'll make sure to do that. And let's see if I can just get a new blank document here. Moss streams. All right, so we'll just go with that for now, and I'll switch back over here. And I would say that I'm not a Figma expert by any means, but I do use it for a lot of the artwork on my posts and that sort of thing. So you may have seen it. If we look at something recent, like this one, this is all made in Figma, and it's a little more exact. You can do a lot more, but you actually kind of like lose out on some of the quick prototyping of Excalidraw. But kind of the idea I had for using Figma is that we could just kind of do a 16:9 for each show. So for example, I could take this and we'll call it Moss 10, just today. And then everything we do, I'll just keep it kind of in this slide, and this will be kind of a record for us going on. And we can just create, more and more of these. So I could, for instance, duplicate this, call this one, or this one rather, Moss 11, and we'll have it set up and ready to go for next time. All right, so per usual, I want to start off by talking about maybe some things that we're going to work on today. So let's get our to-do going up here. Also, one of the things that I would like to do is, let's see if that worked. Yeah, I want to get rid of the bold on the next part. I'm not sure that actually worked. One of the things I would like to do is keep a to-do going, kind of ongoing as we go through all the shows, and also to turn this into a template so I don't have to recreate the to-do each time. So one of the things I wanted to talk about today was, since the last show, I got a variable set up. So variable. Why does it not seem to like that I don't want it underlined? Or, there we go. Variable setup. Let's say review variable setup. And let's make this actually a checklist here. Review variable setup and review CPU control unit testbench. And continue work on control unit. All right, so that can be our kind of high-level goals for today. And we'll see what we go through. So anyway, in the, let's pull up variable here. So variable is, as it says here, a suite of system Verilog developer tools, including a parser, style linter, formatter, and language server. And so what I am doing is, one, setting up variable for linting. So if we type in variable Verilog lint here, we can lint any of our RTL. So let's take our control test bench, and you can see we have a linter error there, and I think it should give us, yeah, so an error code. And let's just show doing one that doesn't have any. I think control, nope, control is not good. Let's say UART TX. It's not honoring my variable rules here. I can't remember exactly. Help full rules config. There we go. So I need to do, if you wanted to lint that, let's do the UART-TX again. And I'm going to say just rules config search. And I don't think I have to provide it any. Yeah. Oops. Is it going to honor it if I put it before? Let's see. Rule. Oh, you know what? I'm on the wrong branch here. So I don't have the rules config. Let's see if we can actually get checkout main, get fetch upstream, get merge upstream main. All right, and then I'm going to say get checkout instruction decoding, which is what we were just on. And I think we can rebase on main. Yep, okay. So now we should see that I have my rules variable lint here, which is going to correct a couple of those warnings. So variable is focused on system Verilog, and obviously we are just using Verilog here. So there's a couple things I turned off or configured that are just system Verilog specific. Also, it looks like Thea's in the chat. Thanks for joining, and thanks for the kind words. Yeah, I love making these streams, so I'm glad they're useful for some folks or interesting. So let's get back and try that rules config search again. Yeah, there we go. So we should have a 0 response. So yeah, so linting is successful there. So that's great, and we have our rules variable lint here to configure that. The other part I wanted to do was set up the language server, and I'll show you with NeoVim. And so I'll show you what that looks like. So if we go in the control test bench where it wants us to correct some of these here, which I'll do in just a moment, then we sorry. Oh yeah, it'll also auto format for us, which is really nice. That was actually the biggest thing because I kept having all sorts of formatting issues. So this is really nice. But the way this is working is, let me open this up and let's go over to my neovim config, config nvim init.vim, and I have all my plugins from before. And then I think if I look for variable, so this is basically what I added here, that we just want to use the variable Verilog language server here. So require LSP config per usual with neovim, call variable setup, and then I added that rules config search, so it'll look for mine. And then I also added the after write, so I think after saving on Verilog files, that we want to go ahead and format those files. If we take a look at this, whoops. Here, let me just grab it like this. Having a slow brain day. Well, we'll yank that over. And I am going to just jump into here. And Verilog, I think tools maybe, language server, and then we get our setup here, neovim. So we can go down here and it kind of gives some of that information. So we have that neovim LSP config, and if we open that up, you can see a bunch of other config you can do here. But if we open that up, then in the wiki maybe, I'm trying to remember where, let's see if I can just find it by searching here. Variable, I think it might be in the wiki. Variable config. Also, I need to turn down the volume on this machine. Language specific plugins. Here we go. It was right in front of my face. Cool, yeah, so here's variable, so you can see I got some of this from here. Specify the command, and then let's see if I actually specified, it looks like I didn't even specify Verilog specifically, but that auto format is just on .v extensions, so. All right. So now that that's set up, like we just saw, I can get some of that auto formatting and then some of these lengths. So for instance, it wants me to specify these explicitly. Branch, I think this is what it wants. Let's see in top here. I guess I missed some of the formatting fixes. I also merged a PR updating some of this. Yeah, so it looks like I missed this one, the top file here. Cool, so let's go jump, mem read, mem to reg, oops. ALU op. Right. So these are just all of our control signals that we've been dealing with on the past couple streams here. Reg, right. All right, and looks like our linter issue is gone now. So this was the test bench we wrote last time, where we were basically alternating between, I think it was add and add immediate, maybe. And I'll pull up Vivado here to get us going. And I think I set simulation sources here. It looks like it didn't save actually my updates here. Look in hashdan code GitHub moscomp mos, and we added these two. And they're not called from top right now, so we'll see if, here we go. Let's see if I can just run simulation here. Yeah, it looks like it only does it for the actual top that we have. Let's see if I can just run. I know if I set as top, I can use it, but let's see. Verilog or Vivado run simulation for one module. This does not seem to be super helpful, in my opinion. Simulate submodules only. In GUI, if you modify the test bench after simulation launches, then the quickest way is to click on relaunch to recompile the files and rerun the simulation. Run for let's see. That is not doing what we want here. Let's see if I just hit run. If I do run all, if it'll give me the. It doesn't look like it. Let's set as top and see if we can get back. And another thing I want to do here is maybe we'll have some questions section. questions. How to run simulation on a single submodule in Vivado. Also wanted to have a ideas section. Blog post on setting up variable with NeoVim specifically for Verilog. All right, so now let's try to run simulation. See if this updates for us here. Run all. Does not seem like it did. Let's try it here. Detected error. Ah, got a typo. ALU source. Runs a little bit slow, it looks like. Seem to remember it going a little bit faster last time. While it's doing that, I wanted to jump back over here, and we were going to continue working on adding our various opcodes. So let's go over to docs. I think it was in ISA. So we have register ALU. We have ALU immediate. Load instructions. So we can go ahead and add load here. Local param opcode load equals 5B, and it's 00100. As a reminder again, we don't have to consider the lowest 2 bits of the opcode because those are always 11 for all the ones we've been looking at. Okay, so we have our load instructions, opcode, jump, indirect, 5B, 1101, 11001. Store instructions. So let's say opcode store, and it is 01 1 2 3. Opcode branch conditional, and we'll say 11000, and jump and link. Oops. Jump link, and it is 11011. I think that is all we need there. And then we just need to add for each of these. Opcode load. And we can say what the control signals are. So branch is 0, jump is 0, mem read is 1, mem to reg is 1. Right, we're gonna take the memory value we read and store it to register. ALU op is 0, 0. Mem write is 0. ALU source is 1. Reg write is 1. All right. We'll say opcode jump indirect. Branch is 0, but jump is 1. And remember, we introduced that new jump instruction here, or jump control signal rather, while we were looking at that MIPS diagram. So basically, if jump is high, we just always select the jump instruction. We don't care about branch or anything like that. I can't remember if we actually... So yeah, branch is going into deciding whether we take the PC plus 4 or the PC relative branch target. But if we have jump, right, we're selecting the shift left in this diagram here address anyway, so we really don't care about that. So I guess we can just, in the don't cares, I guess we'll just set them to 0 for now. All right. Opcode store. Branch 0, mem read 0. And mem to reg, don't care, so we'll just put it as 0. Note that for now. ALU op is 0, 0 because we're saying determined based on funct 3. Mem write is 1. ALU source is 1. Reg write is 0. Okay, branch conditional and jump link is the ones we have remaining. Branch conditional. Obviously missed the non or un. Oh, well, that was silly. The jump instructions are the direct. And we talked about some of the addressing modes here. Conditional. Branch conditional was, so we branch is a possibility, jump no, mem read is 0, mem to reg said 0, we don't care. ALU op is 0, 1. mem write is 1, ALU source is 0, reg write is 0. Okay, the part that I think we left off last time in some of the questions here was sorry, we'll do this. How to handle storing previous program counter in RD on jump or branch instructions. Because right now we do want to write PC plus 4 back. So for example, when we looked at this JLabel example, so when we are jumping in MIPS, I believe that it's not storing the previous program counter. But you know, on the branch it should. But I think what I was confused about is, write PC plus 4 to RD on branch instructions. Here it looks like the write data is either coming from the ALU output, which the program counter is never going into, right? In fact, we have the PC plus 4, PC plus 4 signal coming out of here, and the only place it sometimes gets sent back, you know, for the next program counter, but it does not ever get written to a register, which in the case of RISC-V, on both the jump and the conditional branch instructions, in fact, I meant to have that open. Let's see if we can get manuals, RISC-V spec, control transfer. We have RD for the unconditional jumps, source address of the instruction following the jump PC plus 4 into register RD, and then for conditional, I guess we don't store it, right? Because we don't have an RD. We don't specify. RISC-V jump and link with the destination is hardwired 0, 0 register. Instruction should always be used for unconditional branches instead of a conditional branch instruction with an always true condition. RISC-V jumps are also PC relative and support a much wider offset range than branches and will not pollute conditional branch prediction tables. This is a really good point here. Let's see if I can grab a screenshot of this. We can take some notes. So I'm going to grab that, and let's see if I can just paste that into our doc here. Whew, certainly did paste it. I want to scale this. There we go. No, we don't care about that. From the RISC-V RV32I section. So what we're saying here is we could, let's say this, we could take the an unconditional branch could be achieved by a conditional that is always true, or via a jump and link instruction that does not store the store PC plus 4, let's say, and it's giving us some reasons why we should use the jump and link instruction instead. So use JL because that much wider offset range, and we talked about that on a few streams. I think one is plus or minus a kilobit, and the other, so plus or minus 4. Oh yeah, so plus or minus 4 kilobits or plus or minus 1 megabit, right? So that's why that we want to use jump and link instead. Much wider offset range, so we'll note that down, plus or minus 1 megabit versus plus or minus 1 kilobit. Or is that megabyte? Yeah, megabyte versus kilobyte, sorry. Much wider offset range and conditional. Yeah, exactly what it says. Doesn't pollute conditional branch tables. So I think that second one is really the more interesting point to me. So if we are determining, if we are using an algorithm to predict whether a branch is taken or not, we don't want to confuse the unit. Why is that not wrapping? I want the default to be wrap. We don't want to confuse the unit by giving it a branch that is always true, i.e. could, like a bad heuristic, I guess. So that's pretty interesting. All right, also checking in on this, we reviewed the variable setup, also made some fixes, so that's good. Conditional branching, did we go through this? Yeah, 0, 0. Looks good. And op link, or jump link is the last one. Opcode jump link, jump and link register. So indirect jump. We have 0. This is always a jump. Memread 0, mem-to-reg 1. We are going to write that program counter to the register. ALU op is 1, 0. Memwrite 0. We're not writing anything to memory. ALU source is 1. ALU source should be a don't care, right? Because we are not using the ALU. Let's see. ALU source comes in and it says, is it a sign extended immediate or is it a value read? So I think for both jump and link and jump indirect, we don't care. And I guess that's true for the ALU op as well. I don't remember why I set ALU op to 1-0 here. Oh, well, okay, so I did notice. So maybe let's undo what we just did there. So maybe we are using the ALU, because I noticed here that funct3 for jump and link register, where we're using a sign extended immediate and adding it to the value in RS1, that it has a matching funct3 with add immediate and add. And I think jump and link, so we don't have funct3 with jump and link, and so that's the part where I think jump and link we want to go. You know, this is once again looking at a MIPS example, but jump and link we basically want to go up this way and just calculate that immediate, and then with jump and link register we want to actually use the ALU, because we need to fetch the value from the register. So ALU source is definitely 1. I think with ALU source 0, I think this is going to be a don't care. And then, yeah, that was another blog post idea we had last time, was blog post on why add immediate and jump and link register all have the same funct3 value. The answer is they are telling the ALU to perform an addition. All right. So we have these. As I said last time, we do not have our 64-bit instructions added here quite yet. And so we'll keep those as to-dos for now. But right now, we are done with our. Let's actually see if I can. Well, never mind. We're done with our setup here for control signals. So what I thought would be interesting to do would be to actually compile some instructions and kind of feed them through here. So actually, I'm going to do a few different things here. So let's move this over. Get status. Get add docs ISA. RTL top V. Get add. We'll leave the tool chain alone for now. Actually, sorry. Get log. So the last 3 here, I want to squash. Rebase dash I head 3. Change squash. That's fine, because I'm just gonna Oh. Oh yeah, okay. So these were all just basically, let's see, get stash pop, because they're all new. Uh, let's move this out as just a placeholder here for now. Okay. Get restore staged. Get status. All right, that looks good. Get log. All right, so we're even with main now. And then I also wanted to get the handle that default lent Verilog default case. We'll just say default, I think. Oops. Begin, end, and let's just set everything to zeros. And in the future, we'll raise an interrupt if that happens. All right. Cool. Let me make sure that we have everything. Okay, yeah, this looks all good. What is in our stash changes here? RM, ISA, temp. All right, looks good. Okay, and in our docs, I might want to reorganize these a bit. But I think I have, so I was going to see if I could, no, RISC. Oh, they're not in the tool chain I have for RISC-V is currently installed. It's related to Zephyr and the one that it installs. So I'm going to grab. I also thought about using Rust here, Right now, we could try the. It doesn't have RV64i, but it does have RV32i. So maybe actually we'll give that a try. It always gets upset about Rust Analyzer when I do this. RISC-V. So we have Linux variations. Yeah, we don't have any of the. What tier are these? These are tier 3. In tier 1, we have RV32i. Host tools. Oh, tier 2 without host tools, I see. RISC-V 64. Didn't we see that in tier 3 as well? Oh, that's with Musil. Okay. Invalid toolchain name. Oh, sorry, it should be target. What is the command? Rest up target add. It's because I spelled target wrong. Let's actually be documenting this. We can say, let's say rest. Set up. And obviously we are 64-bit, but right now we only have support for the 32-bit options. Supported targets here. Oops, platform support. All right, and let's go ahead and get our software directory started. Let's see if we can also find this. So we don't have tool chains because, oh, this is still running. I don't know which one of these is the... I guess it's just Vivado. Let's see. Oh. I guess that was not it. 10621. Yeah, these are all on... oh, that seemed to have gotten it, maybe. Why are all of these still running, though? Let's see if I restart that now. If it will honor the changes that we have. Of our constraints. Set as top. Oh, no, I want... Yeah, okay, well, that actually works. Interesting that the test bench... Oh, it's because it references, yeah, okay. Well, that's annoying. See if that stops it. Okay, yeah, that seems to have done it. Let's just remove these. Remove all of these. See if that helps out here. Simulation sources. Because this certainly ran last time. Anyway, we'll keep progressing on the Rust side here because I want to just get to the place where we're compiling something. So since we don't have toolchain support, let's see. Running tools like RISC-V and Cargo natively on the target. Oh, so we don't care about that. We just want to cross compile. So that's not too big of a deal for us. I do want to see how we want to structure the project here. So cargo book. Workspaces. All right. So I think we're going to have a number of crates here. Or packages, rather, I guess. Cargo. And so I think we just stick workspace in there. Is that right? and then we can use cargo new perhaps. I also wonder, so I know there's some good build tooling for Rust, and so we might actually just use it to orchestrate everything. Cargo X task, or let's see. If you had a workspace previously, you'd add X task to your existing workspace cargo.toml. Yeah, let's look at. I think they. I was also looking at this in Oxide Computer GitHub. I think they use this in Hubris, maybe. So they have task. Let's check here. Task. So yeah, this is what I was thinking about potentially using X task to do a variety of these things. To be honest, though, I don't. I think it would be cool to do things like run simulation and whatnot with cargo as well. Yeah. Hey, let's go for it. Why not? So I think if we're going to do that, we actually want to move this out of software. Oops. All right, and then in our cargo.toml here, we'd have workspace. So that's good. But we need to grab. Oh, where was I? Cargo new. Yes, we fully plan on adding this. So we just have X task right now. And let me see if when I pull up Rust Analyzer, if it's looks like it's not triggering Rust Analyzer right now. Let's see. Okay, it looks like it's running. Cool. Okay, and then in software is where we want to start building something that we could compile. So, for example, geez, this is still running. So let's grab this make directory dot cargo, and we'll say config.toml. But we don't want that. We want RV32i. What was it? RISC-V 32i unknown none elf. None elf. All right. And then let's go and do software, and we'll just stick it in here for now. Examples, cargo, new, bin, hello. And I think that we can then add this to our top level with maybe just path relative examples. No, sorry, software examples. Hello, perhaps. Can this format for me, please? Oops. All right. So I think it will be the default package now. And let's see if we can build some stuff. Really just what I want to do is getting started. Can't find crate for test. Oh my goodness. We'll come back to that in a minute. See if that got it. Vivado simulation runs forever. Oh, maybe maybe my simulation runs forever. That could be a factor, right? It doesn't though, is the thing. So let's see if we can say. So it is the top for critical warnings. Those are just from the constraints file. All right, this all looks fine. Executing analysis and compilation step. Runs forever. Worked for me. Oops. Let's try this. Reset simulation. There we go. Huh. Well, I don't know what the issue was there. But here we can see that we do have our simulation, in fact. So that's nice. And this is what we saw last time. Cool. Okay. We don't have standard. All right, so we already have our target. Let's see what happens if we try and build. Let's see. So we want to set cargo config for subset of packages. Per package target, that's cool. Let's see here. New syntax requires a cargo features key. Package.target. Per package target. I thought this would go in the... It first makes the package to be compiled by default. Let's look at the cargo.toml here. Cargo config. Oh, okay. So we can just stick it in the hello directory. Or maybe we should just stick it in all software, right? Let's see if it'll honor that, despite it not being a... Panic handler function required but not found. All right, let's grab that panic handler. Oh, that's a crate. So a panic handler, panicking. Let's take a peek at that. Let's check containing information about the location of the panic, given that embedded systems range from user-facing to safety critical. Let's see. Let's just look at some of these examples here. So let's just see if we can get it to be okay. found, duplicate the ling item. Let's just loop forever. Which test depends on? Seems like it's getting confused here. Not found in this scope. Oh, use core panic info. That makes sense. So I can use all the core, right? But we just can't use standard here, so that's fine. What is personality? No main, no standard. Oh, nice. This is on the Pico SDK here. Which, speaking of Pico, end up having a few of these right on hand here, leading up into SuperCon next week, with some fun stuff planned. Okay, so it seems like maybe it is not picking up the cargo config. Whoa. Yeah, examples. Hello. Package. Cargo. Help. Package. ID. Okay, there we go. So it seems like it's not considering the nested cargo config here. For a particular package was global, it looks for configuration files in the current directory and all parent directories. If, for example, cargo were invoked in. Oh, well, that's not necessarily the most helpful if I have to invoke it from in there. Present when being invoked from a workspace, cargo does not read config files from crates in the workspace. The workspace has 2 crates in it named whatever, and there are cargo configs. That is annoying. Well, we can note it down at least, that it was able to build it. So let's just copy that over into our docs here. But I guess we could try to use the attribute that was mentioned there in our cargo.toml. From workspace root. Function main is never used. So let's actually look at the, let's target debug examples. Oh, hello is right there. Let's just list the size of all of it. So hello does have some contents. So we could take a look at what's happening in there. Oh man, that's going to be annoying. Let's see. Dot rust up tool chains stable. So yeah, we don't have the no, we should have the tool chains. We should have the tool chain for RISC-V, right? We just don't have the all the host tools. Let's see if I wrote that down in that blog post. Oh, okay, lib rustlib. That's where it is. Hold on 1 second here. All right, so it's in rust up, toolchains, stable, lib, rustlib, RISC-V 32. Where were we? Oh yeah, I actually dug through here. That looks like a typo. Cargo build. Wow, I went through way more than expected there. Let's take a peek here at, well, we'll add this. Rust libraries. So we still have core. Trying to remember where I had my RISC-V toolchain, which we can grab actually from this blog post. Toolchain, local. Zephyr. I want to say, so I have RISC-V 64. Then, yeah, we should probably just get the, well, let's see what readoff gives us here. Debug. Hello. We want all. Oh wait, no. It is just a lowercase a. Kind of unexpected. So we can use this, which is helpful, because I believe that target RISC-V debug hello. Maybe this will actually give it to us. I don't think it will. Oh yeah, okay, it still will. But let's see if like object dump will. Disassemble all. Yeah, can't disassemble. So let's grab object dump from here. And that is able to disassemble, which is helpful. So we could take this apart and see what's actually going on here. But anyway, that is a pretty good setup for us. I'm going to note that down. Obviously, this isn't going to be useful for that many people. Oh, John's here. Hey, John. Thanks for stopping by. Hope all is well in the new gig. It looks like y'all are doing a lot of fun stuff. Love seeing it. All right. I think I'm going to have to wrap up pretty soon here, which this has been quite the hodgepodge of examining things. I feel like the biggest like RISC-V takeaway from the spec today is the why we use the jump and link rather than the conditional branch with always true evaluation, which we obviously noted down up here. We were able to run the control unit test bench. And continue to work on it. Okay, so I feel like this is cheating a little bit. I feel like we didn't actually. I mean, we did get the control unit done, but that was a very short period of time that we spent. But I wanted to actually generate some instructions to actually send through it, which maybe for next time. Let's see. For next time, maybe we will test out using Rust assembly, and then we'll go from there. You know, actually, I want to look at a few things real quick. It'd be fun to go through here and basically in this no op, see if we can find, just break it down for everything that's happening here. Section, comment. But we can see all of the, or some of the RISC-V instructions that we've talked about here. We should talk about the 2-byte and 4-byte here. Assembly guide. Yeah. Dot 2-byte sudo ops. I'm gonna go ahead and link this because we're definitely gonna need it. Assembly programmers guide. And I actually feel okay about maybe merging some of this. Maybe I'll leave off the don't cares for now because I might want to come back and reevaluate them. But based on the jumps, we had the don't care on, or on the indirect jump, we had the don't care. On the store, we had the don't care on the memory to register. Let me pull that open again. So our mem to reg is oh yeah, if reg write is 0, then we pretty much never care, I guess, on mem to reg. So this reg write might need to change for jump and link because we need to write the PC plus 4. Anyway, we can come back and revisit that. I'm going to have to wrap it up for today. But thanks to all who joined. We got a pretty long stream in here. Definitely some more organization I think I can do ahead of time. But it's always fun to get on here, explore things, make some progress here on Moss. And yeah, hope everyone has a great rest of your weekend. And hope you get some time to do some hacking. Have a good one, folks.